All right, so the last lesson that we did, we talked about finding the solution to two lines using graphing. Now we're going to look at how we can do that when we don't have a graph available to actually solve. So the first thing that we're going to do is we're going to look at these two images and just state everything that we can about them. So in image one, I can see that they intersect right here. So they intersect at the ordered pair of 4, 4. Line 1 has a positive slope, and line 2 has a negative slope. If I look at this one right here, I can see that it intersects at roughly 3.2, and I'd say about 4.8. So it intersects at 3.2 and 4.8. Line 3 has a positive slope, and line 4 has a negative slope. Now, if we talk about which image we are absolutely certain about the point of intersection, it's going to be image 1 because that one is on the crosshair. So image 1. This point is at a definite spot on the grid. Awesome. So if we move on and we start looking at some more things, can we think of a method to solve for the point of intersection that may produce a more accurate answer? For this, we would use substitution. When we substitute a value, it means that we can go through and we can get exact results. This gives exact results. So for instance, we're just going to start off here with a very simplified version of it, and I am going to determine the y value in my fifth equation, which is 2x minus 1, when x is equal to 2, which means I'm going to go y is equal to 2 times 2 minus 1, which is 4 minus 1, which is 3. For the second one, I have L6 is y is equal to negative, again, I'm going to substitute 2 in, plus 5, which is equal to 3. So what do we notice about the y values of the two lines when x is equal to 2? They are the same. Therefore, their point of intersection is 2, 3. Awesome. Now we're going to take a look very briefly at problem 2, which has how many solutions will there be to the system of equations y equals negative 2x plus 3 and y equals x minus 3. We know that there is one solution. This is because they have different slopes. This is review from last lesson. And one thing I do want you to keep in mind, especially for the next example that we're going to do, at the point of intersection, x and y coordinates are always equal to each other. So now we're just going to talk about some steps when using substitution to solve for that. So if I am using substitution to solve that, my first step is to make sure they're in y equals ax plus b form. This is because I want y to equal to y and x to equal to x. Then I'm essentially going to, step 2 and 3 is to write down what is on the right side of those equations for both sides. So I'm going to write down ax plus b, ax plus b. When I do this, it's essentially going to mean ax plus b from equation 1 and ax plus b from equation 2. Then I can solve for x, because at this point, I'm going to take x from both equations and make sure that they are the same. Once I know that value, I'm going to substitute it into either one of the equations and solve for y. I can then double check my answer by substituting it into the equation that I did not originally use, and then write my conclusion statement of, therefore, the solution is yada yada. So when I take a look at this, we're just going to do an example. Say I have here equation 1 is 5x minus 4 is equal to negative 2x minus 11. I'm only writing this stuff down. I can now solve for x. So when I do this, I'm going to bring this over and it becomes positive 2x. So I will get 5x plus 2x is equal to, bring my negative 4 over to become positive 4, negative 11 plus 4. I'll get 7x is equal to 7, which means if I divide both sides by 7, I get that x is equal to 1. If I substitute that back into one of my equations, I'll get y is equal to, I'm going to use the first equation, 5 times 1 minus 4 is equal to 5 minus 4 is equal to 1. This means that now I have both the x and y value. Bear with me, I just realized there is a minor mistake. This should be a negative 7x, so this should be a negative 1, which makes that a negative 1, which makes that it. So it should be negative 9. That was my bad. Equals negative 9. Now, if I go through and I double check that, I'm going to take, say, my first equation again, or sorry, I'm going to take my second equation, y is equal to negative 2x minus 11, and I'm going to substitute these points in. So I will get negative 9 is equal to negative 2 times negative 1 minus 11 is equal to negative 2. Sorry, positive 2 minus 11 is equal to negative 9. Left side equals right side. Therefore, my solution is negative 1, negative 9. Let's do that one more time, and let's hope I don't make a mistake this time. Awesome. So again, x plus 7 is equal to negative x minus 3. I'm going to take my negative x over, and it becomes positive x, so I'll get x plus x. I'll bring my 7 over, and it becomes negative 7, so I'll get negative 3 minus 7. This means I will get 2x is equal to negative 10, so x is equal to negative 5. So I'm going to divide both sides by 2. Awesome. Now, if I substitute that back in, I'm again going to pick the first equation. So I'll get y is equal to negative 5 plus 7. So y is equal to 2. This means that I have x equals negative 5 and y equals 2. I'm going to substitute these into my second equation. Y equals negative x minus 3, which means 2 should be equal to negative of a negative 5 minus 3, which is positive 5 minus 3, which is 2. Left side equals right side. Therefore, my solution is negative 5, 2. Awesome. So now we are going to determine the solution to the system of equations y equals 4x minus 3 and 6x minus 3y plus 21 equals 0 algebraically. This is essentially the same exact thing we just did. I just want to make sure that when we do this, we follow all the steps without necessarily having the chart there for us. So if I go through and I know that I have this first equation, it is not in y equals ax plus b format. So my first step is going to be to rearrange it into the slope y-intercept form. When I do this, I'm going to bring my 6 over, becomes negative 6x, bring my 21 over, becomes negative 21, so I will get 3y is equal to negative 6x minus 21. I'm then going to divide both sides by negative 3. And that is going to give me y is equal to positive 2x plus 7. Awesome. Now I can go ahead and start my steps of 4x minus 3 is equal to 2x plus 7. I'm going to solve for x, so I'm going to bring my 2 over. It becomes negative 2x. Bring my 3 over. It becomes plus 3. And I will get negative 2x plus 4x equals 10. This is 2x equals 10. If I divide both sides by 2, I will get x is equal to 5. And now I can substitute that back into one of my two equations to solve for y. So essentially, step 1, 2, we're just going to go 3 over here. I'm going to take the first equation, y is equal to 4 times 5 minus 3, which is equal to 20 minus 3, which is equal to 17. Now, if I'm going to double check that, I'm going to go 4 over here. I'm going to plug it into the other equation. I am going to go with y is, or 17 is equal to 2 times 5 plus 7, which is equal to 10 plus 7, which is equal to 17. Left side, right side check. Therefore, the solution is 517. Awesome. So let's try that again. We've got to rearrange this equation to start off with. So I'm going to bring that over and have it become negative 8x. That over to become positive 50. So I will get 2y is equal to negative 8x plus 50. Divide both sides by 2. And I will get... Just going to move this over. Y is equal to negative 4x plus 25. Negative 4x plus 25 is equal to, I've got to rearrange this one as well, and that's just going to be negative 2x. Negative 2x plus 11. Now I can solve for x. So what I'm going to do is bring this on over to this side and make it plus 4x. This over to this side, make it negative 11. So I will get 25 minus 11 is equal to negative 2x plus 4x. If I take a look at 25 minus 11, that gives me 14 is equal to 2x. Divide both sides by 2, and I will get x is equal to 7. If I solve for y, that means I have y is equal to negative 2 times 7 plus 11, which is equal to negative 14 plus 11, which is equal to negative 3. I can substitute that into my other equation, which was y equals negative 4x plus 25. So negative 3 is equal to negative 4 times 7 plus 25. Negative 4 times 7 is negative 28 plus 25. It's equal to negative 3. Left side, right side. Therefore, the solution is 7, negative 3. Awesome. We've got a few more examples to go over here. So Jamie goes to the pet store to buy some budgies. Red budgies cost $9, green budgies cost $3, and he needs a total of 10 budgies. If Jamie spends exactly $72 on birds, how many of each color did he buy? So when we take a look at this, we're going to let X represent red budgies. And we are going to let Y represent green budgies. So when we do this, I know that I need to figure out how many birds he bought of each color. So we know that Y plus X is equal to 10 because he bought 10 birds. Terrifying amount of birds, but we'll go with it. If I rearrange this, I will get Y is equal to 10 minus X. I know that when I take a look at this, and this is where a standard form can come in handy, I can make another equation stating that if X is equivalent to red budgies, that means that I have X, he paid $9 per red budgie. Plus, he paid $3 per every green budgie, which is represented by Y. And he spent $72 total. So now if I take a look, I know what Y is equal to, and I have another equation. I can substitute Y in, and I will get 9x is equal to 3. 10 minus x is equal to 72. This is supposed to be a plus sign here. Then I have to use my distributive property, and I will get 9x plus 30 minus 3x is equal to 72. I'm going to combine my like terms, which is all just revisiting the last units that we did. 6x plus 30 is equal to 72. I'm going to isolate x on its own. So I will get 6x is equal to 72 minus 30 is 42. And my last step is going to be to divide by 6 to get x on its own. 42 divided by 6 is going to give me 7. So based off of this, I know that he bought 7 red budgies. I'm now going to have to sub my x value in to solve for y. So I know that y is equal to 10 minus 7, which is 3. Therefore, he bought 7 red budgies and 3 green budgies. Awesome. And that's everything for today's lesson.